Good morning, everyone. Like the previous distinguished speakers, I'm also going to start a little bit down a memory lane and ask myself, or ask us, what can we learn from history? Because I was also around 2013, where a lot of the promises around SDN and NFV were made, and many of us were. I think some of these promises is still what we're striving for. We're striving for an agile network with short time to market for additions and features. We're looking for a flexible network with no vendor lock-in, possibility to use best-of-breed technology on all sides. We're looking for lower OPEX and CAPEX for the network. We're looking to create a platform for 5G and IoT with new services. And we're looking for automated operations. This was the credo back in 2013. So where are we now? I think we've seen some great examples here. We saw Verizon, which I think is one great example of progress putting SDN and NFV into operations. From Ericsson's side, we have more than 55 live networks right now based on SDN and NFV technology. So no, millions of users right now live based on this technology. That's progress. Still, I think we can agree that this has not been as fast as we hoped for. It has not been as smooth and as anticipated, and there are still many challenges left. It's proven quite hard to integrate SDN NFV. I think we've all seen evidence of that. We've also seen that a lot of new complexity has been introduced. There are many variants, many combinations of these layers that need to work together. Takes time. We've seen operations changed. Maybe that's the biggest challenge. And in some cases, we haven't seen operations change, which is perhaps an even bigger challenge, because trying to operate a cloud network in a physical way is a no-flyer. There is no perhaps lack of standards, perhaps there are too many standards, as we've seen in previous charts here. A lot of open source initiatives, in some cases, competing with each other, which also creates fragmentation and slows down industry. And then I think from a sort of troubleshooting and operations point of view, there is this responsibility question that was also touched on before. New type of responsibility matrices asking the question, who's responsible, not just to build, but also to operate and troubleshoot, of course, the solution. And we don't have time, because SDN and NFV networks are the basis for 5G, and 5G launches have in fact already started, as we saw last week. So we need to make this work. So what are the learnings we can take from history? Well, there are probably many learnings, but we try to boil them down into three. Number one, openness is super important. In order to get this going with all kind of multi-vendor configurations that will and need to happen, openness needs to be there from start. Having said that, solutions need to be industrialized and pre-integrated. Otherwise, it's just going to add cost and it's going to add time. I think second learning is that the early technologies, this is a technology point, the early technologies of NFV still lack a number of the key attributes needed to run telco networks in the right way. Let me give you one concrete example. A virtual machine is not more stable than a hardware board. It's in fact less stable. That means that the applications running on top of that need more resilience, not less resilience than they used to have in the past. So this is something we also need to fix going forward. And then, of course, operations. You need to address operations. This is probably the single most important thing. It's not, the key thing here is not technology. It's perhaps not even the key challenge. The key challenge might be people, operations, and processes to fully reap the benefits of what SDN, NFV, and cloud technology will give you, where automation perhaps is the key enabler to put into place. So, three key learnings taken with us going forward. So what can we do about it then? Well, let me give some few key steps to take. First of all, we need, of course, to continue to evolve the SDN NFV platform. We need to make sure that this now becomes the basis for 5G systems, not just for consumer mobile broadband, but in fact for different kind of growth opportunities for us as an industries. Growth opportunities in industries, verticals, be it manufacturing, be it automotive, be it healthcare, etc. We need to make sure that we continue to build on openness and to build on different layers in the cloud, but to expand that also, not just to central data centers, but in fact also to decentralized, distributed cloud deployments, including edge compute. We need to make sure that this becomes the basis for many kind of different workloads, not just the usual telco workloads like packet core or voice over LTE, etc., but ranging all the way out to virtual RAN applications and all the way up to third-party applications, both for consumer and industries. We need to make sure that orchestration is there from the beginning. And last but not least, we need to make sure that this is built on openness and that we make best use of the open source and standardization bodies out there. Not too many, not too few, but the right amount. I gave a few examples here, which are some of the key bets, not a comprehensive list, but some of the key bets I suggest that we take as an industry. Our commitment from this is that we will continue to invest to make this work together. Our commitment is also that we will make sure to harmonize towards openness and also harmonize some of these initiatives. For example, ETSI and OwnUp from an orchestration point of view. The second thing is about technology. We of course need to embrace the journey towards cloud native design principles. The agnosticity of applications running on any kind of cloud environment is one key principle. The decomposition of software to make sure that small pieces of software can be lifecycle managed in a much faster way than today's large chunks. The resiliency of applications should of course be enhanced to cater for some of the critical use cases of 5G, but should also be able to rely more on, for example, container-based orchestration mechanisms, rather than to build in everything into complex application solutions. State optimization is important, to rely on data, to rely on common data layers in the network. Automation from day one, and of course performance, making sure that we get as much performance and as much resource efficiency out of the underlying cloud system as possible. Those are the design principles that form the basis of building a system of network slices that are orchestrated as network slices, built on modular microservices, where each application then is built up of small, modular, interchangeable microservices that can fast be adopted to the specific application and also the specific operating model required for a certain industry or a certain application. This is where we need to go from a technology point of view. Third step, around operations. And it goes without saying that the key here is around automation. And it's automation of different aspects and different things. Of course, it's about the basic automation around test and onboarding, because this is where we spend a lot of the time today. The simple process of getting a new piece of software from, for example, Ericsson into the network. Lose a lot of time in that process, so that's one thing to really focus on. VNF management, the lifecycle management of software on top of a network. Service assurance, making sure that we make best use and correlate the data and the insights coming out of a network. SDN is inevitable. To virtualize the networking has not been done to a large extent in many networks today, but to reap the full benefits, especially of scalability and advanced cloud use cases, SDN is a must. So the journey towards automation based on SDN is also something to accelerate. Orchestration comes in different flavors. Of course, the normal NFVO or the NFV orchestration is one, but also service orchestration on a higher level, as well as WAN orchestration to make sure that the entire transport network also follows through in the introduction of new services. And then, of course, analytics. Analytics being the basis for not only insights, but also closed loop automation. It all builds on the right type of analytics. These are a few key steps to introduce both virtualized services, to transform data center operations, and also to build the distributed cloud infrastructure for new services in edge compute. And then it's about people, of course. It's about transforming methods, processes, and tools to run these networks. We're going from the traditional physical networks based on vertical management, probably vertical organizations, to horizontal organizations. Management of horizontal layers for data centers, for NFV infrastructure, for VNFs, and of course for service management. And note, the physical networks are not going away. They're going to be there also. So operations need to take care of this, let's call it hybrid operation. There are different ways to organize for this. There's probably not one perfect organizational blueprint. We're working with many service providers across the world to find the right way to tackle this. But I think one best practice is to keep service management together, because there needs to be one way of service management irrespective on the underlying network. I think another best practice is to make sure to plan for and organize for the horizontal layers of cloud. That's the way to speed up the lifecycle management in a cloud world. So these steps then look simple enough. They need to be introduced in a smooth way and of course stepwise. Some has already been done. 2017 is behind us and many steps were taken there. This chart here shows a few examples of what has been done, for example, with packet core network being virtualized, running on infrastructure as a service, with automated VNF lifecycle management. We have this in operation since approximately 1-2 years in live operation. This year is a big year. It's a big year because the first 5G systems are being introduced. They're being introduced here, I think, as we speak, based on the so-called non-standalone mode, what we call the 5G EPC mode. And more and more of automation comes with that also. For example, automated networking, which is another key enabler to get these SDN NFV networks into operation. It doesn't stop here. Next year is going to be particularly exciting, and the years to follow. Here is where we will see truly containerized systems into live operations, probably on the inflection points of introducing new 5G architectures. We will not only have the non-standalone architecture, but also the standalone architecture defined out of 3GPP based on the 5G core standard. They will coexist together with the existing EPC standard, forming what you could call a sort of dual mode core operation, but running in a cloud native way, running fully containerized, running either in a container orchestration system on top of an infrastructure as a service, or perhaps in a bare metal deployment, depending on if we as an industry can fix some of those challenges around security, integrity, and orchestration that still need to be overcome. And of course, there are additions in orchestration that will come from this. We will have orchestration as we know it today, but on top of that, we have the opportunity to orchestrate microservices on a more granular level for more modularity, higher resilience, and faster time to market. And then also network slices on a higher level, introducing entire services to new industries, to new enterprises in a much faster way than today. This gives us something to keep busy about during the next couple of years. So I'll finish by wrapping up and just saying that we've made many mistakes in the past. It's natural, we're dealing with complex thing. SDN NFV is complex. And I think the only thing to mind about going forward is that we learn from these mistakes, and it's not okay to redo them again. I'm sure there will be new mistakes to make with cloud-native technologies, with 5G, with new ecosystems, but at least we should make sure that we learn from what we have done during the last couple of years, since 2012-13, when SDN NFV was introduced. We need to learn that openness is key in order to get interoperability and in order to get ecosystems going, but we also need to learn that pre-verification and industrialization are important in order to reduce our joint cost as an industry and also in order to reduce time to market to introduce new services. We need to make sure, as a second learning, to build on technologies we have today, based on SDN, NFV, but they will not be enough for the speed, agility, and performance required by 5G. Cloud-native design principles apply also to telecom if we do it in the right way, and they are in fact a necessity for introducing, for example, 5G core, for example, network slices, and distributed cloud deployment. And then last but not least, we need to learn that we need to think about operations. Technology is perhaps difficult and complex, but operation is about people, it's about processes, and it's about managing live networks also, which cannot be taken lightly. It needs to be considered from day one, making sure that the new operational models optimized for cloud deployment, built on automation, of course, to take out cost, but also leveraging full cloud technology. Those are key. And learning from each other here in the room, rather than try to invent our own operating models, is probably the fastest way to get to that target operating model that we all need to be at. So with that, I'd like to thank you for your time today.